So, good morning, sir. Good morning, everyone. I'm making my oral recitation. So, sorry for the background sound, just don't mind it, sir. Okay, I'm here in my lola's house. Yeah, okay. So, I choose this topic, Sohcahtoa. But first, I'll discuss what is Sohcahtoa. Sohcahtoa is a mnemonic device used to remember the trigonometric functions and ratios for the right triangle. So we will use Sohcahtoa only for the right triangles. Now, what is the meaning of so? So stands for sine is equal to opposite over hypotenuse. Or let's try this way. Sine theta equals to opposite hypotenuse, like that. And ka is cosine theta equals to adjacent over hypotenuse. Cos theta adjacent hypotenuse, this one. And TOA stands for tangent equals to opposite over hypotenuse. So, TOA or tangent theta equals to opposite over adjacent, sorry. Yeah. And how to determine where is opposite and hypotenuse? For example, we have a sine here. The opposite of this angle here, this is the opposite, is the opposite, and the hypotenuse is the longest side of the triangle, of the right triangle, and the adjacent is the legs or the side line of the angle. Okay, so for example, we have a given here, we have a given number here and ang given angle. So the opposite angle is we can use the, if we need to find the hypotenuse, so we have the given opposite and we need to find the hypotenuse, so we can apply the sine or so. Sine equals to opposite over hypotenuse. If we want to find the adjacent, we can use the tangent, the opposite and adjacent. But if we need to find the adjacent but only have the hypotenuse given, we can use cosine adjacent over hypotenuse. So for example, okay, we have an example right triangle here, or given right triangle. So we need to find the x value. Sine 40, or this is the angle 40, we have adjacent given, which is 6 centimeters, and we need to find the opposite of the angle, so x. So we can use, as you can see, we can use the TOA, which is TOA equals to opposite over adjacent. Here, tangent 40 is equals to opposite, which is x, equals to 6. Tangent TOA, tangent 40, tangent theta or tangent angle 40 equals to opposite is x, and the adjacent of the angle is 6. So we can write this as this. So to find the value of x, we need to multiply both sides by 6 so that the x will remain inside. So multiply both sides by 6, so 6 will cancel out. So the remaining is x. It will be x equals to 6 tangent 40. And but natin yung calculator. Tangent 40 is equals to 5.03. So x is equals to 5.03, and don't forget the unit, which is centimeters. to review, we have a given right triangle here, and we need to find the opposite of an angle. So we use TOA. Since TOA means tangent equals to opposite, we have opposite here, and adjacent, we have adjacent given. So tangent 40 or tangent theta of an angle, tangent 40 is equals to opposite x over adjacent 6. We cancel out the 6 because we need to remain this x, so that the x is equals to the value of tangent 40 times 6. So x is equals to 6 tangent 40, and if you put it, if you calculate it using your calculator, x will be 5.3 centimeters. Okay, we have another example. We have a given right triangle, and the hypotenuse is given and angle. So now the hypotenuse is now 10 centimeters and the angle is 36, and we need to find the opposite of the angle. So here in Sohcahtoa, what do you think we can use? Can we use ka? We have cosine of adjacent. There's no adjacent given, but we have hypotenuse. But here in the problem, we need to find the opposite. So TOA. But here in TOA, we have the opposite. But then we don't have the hypotenuse given here, or here including in the solution. So we will use opposite, since sine equals to opposite over hypotenuse. So if you will write that sine 36 equals to opposite x 10. Good. Sine equals to opposite of the angle x over hypotenuse. Hypotenuse will be is the longest side of the triangle. So we will find x. To find x, we will multiply both sides by 10, so that the x will be remain and the 10 will be cancelled out. So times 10, cancel the 10, so the remaining will be x equals to 10 sine 36. Here, x equals to 10 sine 36. So you put it in your calculator, sine 36. So if you put this in your calculator, we have 10 sine 36. We have so x equals to 5.88 centimeters. Don't forget the unit. So x is equals to 5.88 centimeters. Okay, we have another example here. Example right, it's given right triangle. We have hypotenuse, which is 15 centimeters. We need to find the adjacent of the angle 45 degrees. Since we have a given hypotenuse and we need to find the adjacent, hypotenuse adjacent, we can use ka, or cosine is equals to adjacent over hypotenuse. So cosine of 45 equals to the adjacent of this angle, which is x, and the hypotenuse of the triangle, which is 15 centimeters. So we can write this like this: cosine 45 is equals to x 15 centimeters. Now don't bind this. So cosine of 45 is equals to x over 15 centimeters. Now, to find the value of x, we need to times both sides by 15, so that we can transpose 15 here and remain the x. Okay. So can we write it? So cancel out the 15. So x will be x equals to 15 times tangent 45. You can use it, or you can solve it using your calculator. 15 tangent 45 will be 15 So the value of this side is 15. The x is equals to 15. So x is equals to 15 centimeters. 15 centimeters. Now to review or to recap, we have a given right triangle here, and we have a given hypotenuse and adjacent and given angle. So to find the adjacent, we can use ka or cosine equals to adjacent over hypotenuse. So cosine 45 equals to the adjacent, which is x, over hypotenuse 15 centimeters, times both sides by 15, so that the x will be remain equals to 15 times tangent 45. Calculate it using your calculator, and x will be 15 centimeters. So now we have another given right triangle. Now we have a given adjacent, an angle, and we need to find the hypotenuse. So as you observe, we can use ka because cosine, because ka stands for cosine, is equals to adjacent over hypotenuse. Since we have a given adjacent and we need to find hypotenuse, so cosine of 32 equals to adjacent is 15 over x. So we can write this as cosine 32 is equals to adjacent 15 x here. And all you need to do is times both sides by x, and then divide both sides by cos. It will have a longer process to find the value of x. So first times both sides by x, it will be cancelled out, and we have x here. So the remaining will be x times cosine of 32, cosine 32 degrees equals to 15. We need since we need to find the x value, we divide both sides by cos 32. Then we have a remaining x is equals to 15 over cos 32 degrees here. So put it out, can calculate it using your calculator. 15 over cosine 32. Now we have the value of x, which is 17.69. So the x is equals to 17.69. The unit here is centimeters, so 69 centimeters. Don't forget the unit. Okay, to recap, we have a given right triangle here, and the given value of the right triangle are the adjacent, the angle, and we need to find the hypotenuse. So we can use ka or cosine equals to adjacent over hypotenuse. So we can rewrite this as cosine 32 equals to 15, the adjacent, and the hypotenuse x. We have a longer process here but accurate. So first, times both sides by x, so the x in the other side will cancel out, and times the cosine of x since both sides. So x cosine 32 equals to 15. Now divide both sides by cos 32, so the cos 32 will cancel out, so the x will remain equals to divide both sides by, as I said, divide both sides by cosine 32, so 15 divided by 32 cosine 32 here. So the remaining in the other side is x. So x equals to 15 over cosine 32. Using your calculator and calculate this, you will have x is equals to 17.69 centimeters. Okay, we have another example of right triangle. We have a given here angle and the adjacent of its angle, and we need to find the opposite angle. So since we have a given adjacent and we need to find the opposite, we can use TOA. because TOA stands for tangent of an angle, which is 32 or 22, equals to opposite x over 300. Okay. So, we can write this as tangent 22 is equals to opposite, the opposite of the angle is x. So, x equals to 300 meters. Okay. Here. Tangent TOA, tangent 22 degrees. I forgot the degrees. Is equals to opposite. The opposite of the angle is x. And the adjacent is 300. Okay? So, tangent 22 equals to x over 300 meters. Now, to find the value of x, we need to times both sides by 300 so that the 300 here will cancel out. So, x divided by 300 times 300, cancel, times 300. 300 will cancel out here. And since you need to times both sides by 300, so 300 times tangent 22. So, x will be 300 tangent, the value of x is equals to 300 times 10, tangent 22 here. So, calculate it using your calculator. Tangent 300 tangent 22. The value of x is equals to 121.21 meters. Here. 21 meters. So, to recap, we have a given right triangle. And every right triangle, if there's a remaining side and there's a given angle, you can use Sohcahtoa. So, as you can see, we have a given adjacent here and we need to find the opposite angle. The TOA is fit for that equation or for that solution. So, the TOA stands for, always remember, TOA stands for opposite over adjacent. So, the opposite of this 22 or the opposite of this angle is x. And the adjacent is 300. So, tangent 22 is equals to x or the opposite over 300 or the adjacent. So, we can write this as like that. Tangent of 22 is equals to x over 300. Now, to find the value of x, we need to times both sides by 300 so that the x in the other side will remain and 300 will cancel out. So, x divided by 300 times 300, cancel out the 300. And here on the other side, 300 times tangent 22. So, we can rewrite this as 3x is equals to 300 tangent 22. And using using your cycle or the calculator, the value of x is equals to 121.21 meters. Here. Now, we'll move along. We will now try the finding the angle. Now, what if we have a given of two sides, but we need to find the angle? We can still use Sohcahtoa. Okay? So, this is, imagine this is the angle. Okay? The angle, the adjacent of its angle is 12 meters and the hypotenuse of the triangle is 15 meters. Now, what can we apply or what can we use here to solve this? So, we have adjacent. So, we can use ka or TOA. Now, we have hypotenuse. So, we can only use ka because we have the given adjacent and hypotenuse. Okay. We can write this as, so, cosine is equals to adjacent, which is 12 over hypotenuse. So, cosine theta, since we don't have an angle, we can just use theta, is equals to adjacent, which is 12 over 15. Now, to get the theta of its own, we don't just divide both sides by cos, but we can use inverse cosine, or you can see it in your calculator. Cos raised to negative 1. So, we can write this as theta is equals to inverse cos raised to negative 1 bracket 12 over 15 here. Always remember that if you want to find, or if you want the theta on its own, don't times both side by cos or divide both side by cos or tan sign. Use the inverse sine, inverse tan, or inverse cos. So theta is equals to cos, inverse cos equals to times or bracket 12 divided by 15. So you can calculate it using your calculator. So inverse cos times 12 over 15. So we have the value of theta, which is 36.87. So the theta is 36.87 degree. You will write degree because we are finding the degree or the theta of its angle. Okay? So the angle here is 36.87. Okay, now we have another example of finding the angle of the right triangle. We have adjacent, this is the angle, adjacent of its angle is 12 and the opposite is 10. So we have opposite and adjacent. So as you observe, we can use TOA. Why? Because TOA is equals to opposite over hypotenuse. Opposite over adjacent. So opposite of its angle is 10. And the adjacent of the angle is 12. So we can write tan theta is equals to the opposite is 10 meters. You don't need to write the unit during solving. You need to write it in final answer. So 12 over 12. So here, the tan theta is equals to 10 over 12. TOA. Tan theta is equals to opposite. So the opposite of the angle is 10. And the adjacent of this angle is 12. So now, as I said, don't divide both sides by tan. Instead, use the inverse tan. So to remain the theta on its own. So using inverse tan, so theta is equals to inverse tan or tan raised to negative 1 bracket or times 10 over 12. Here. You can use that. So theta equals to tan negative 1 or inverse tan bracket or times 10 over 12. So you can calculate it using your calculator. Inverse tan 10 over 12. Okay. Now, we have the value of the theta, or we have the value of the angle. So the angle here is equal to the angle or the theta is equals to 39.80. 39.81 because you needed to round off it in the nearest hundreds. So here. Don't forget, if you are finding the theta, if you're finding the degree, you need to put a degree here. Okay? To recap, we have a given right triangle and we have a given opposite of its angle and adjacent. So we can use TOA since TOA is opposite over adjacent. So tangent theta, since we are finding the angle, is equals to 10, which is the opposite, and the adjacent is 12. And to get the theta on its own on the other side, we don't divide both sides by tan. Instead, we use inverse tan. Okay? So theta is equals to inverse tan times 10 over 12. And using your calculator, you will come up into this answer, which is theta is equals to 39.81 degrees. So the value of this angle is 39.81 degrees. This is 90 because it's right triangle. Okay, now, we have another example of the right triangle. We have a given right triangle. and we have a value of this is the angle, and its opposite side, if its opposite is 10 meters, and the hypotenuse is 15. And we can, so as you notice, we can use the since is equals to means sine equals to opposite of an angle. The opposite of its angle is 10 and hypotenuse 15. So we can write is sine theta is equals to 10 over hypotenuse. So we write this. Sine theta is equals to opposite, which is the 10 over 15. Here. Okay? So, means opposite over hypotenuse. Sine theta equals to opposite, the 10 over hypotenuse, which is 15. So now, to get the theta on its own, we don't we don't divide both sides by sine, but instead we use the inverse sine, or sine raised to negative 1. So theta equals to inverse sine, or sine negative 1, times 10 over 15. Here, theta equals to inverse sine times 10 over 15. You can calculate it using your calculator. Inverse sine is equals to 10 over 15. So we have a value of the theta, which is 41.81. So theta is equals to 41.81 degrees. Since we are finding the theta, we are finding the degrees, don't forget to write degree sign. Okay? So to recap or to review, we have a given right triangle here. And in the given right triangle, we have a value of the opposite of the angle and the hypotenuse of the angle. So we can use because stands for sine theta equals to opposite, and the opposite of the angle is 10, and the hypotenuse 15. Always remember that the hypotenuse is the longest side. Okay? So sine theta is equals to 10 over 15, and always remember that if you're finding the angle, don't divide it by the sine or the cos or the tan, but instead use the inverse sine, inverse cos, or inverse tan. So theta is equals to inverse sine times 10 over 15. So you calculate it using your calculator. So we will come up with theta is equals to 41.81 degrees. Well, you can check it by also using the But instead, let's pretend that we don't have this value, the 15. So sine 41.81. So we can check it like, let's pretend we don't have the hypotenuse. So sine 41 is equals to opposite 10 times x. So times x, or the hypotenuse. So if you will derive it or manipulate the formula or the equation, we will come out to x is equals to 10 over sine 41.81. And if you calculate it, again, if you calculate the x, let's pretend there's no value here, so x equals to 10 over sine 41, we will come up to 15 meters. So if as you can see, if it's correct, the 15, then your answer is in angle is also correct. So thank you, sir, for your time, and thank you for listening to my report. And I'm sorry it's low budget because I don't have a place to do my report, sir, since our house ba is being rebuilt gani. Oh, thank you, sir, for your time. Good afternoon, and I hope akong grado, sir, maluoy ka.